Dear participants of the conference, let me introduce the report on the item Applying Industry 4.0 Technologies to Extend the Functionality of Interactive Water Maps, Bathymetric-based data in environmental monitoring. In modern conditions of climate change, urbanizations and human industry activity, as well as the impacts of agricultural production, alterations in land usage, military operations and other factors, the issue of maintaining sufficient reserves of water resources to meet the needs of the population, animal husbandry and agricultural production require access to fresh and clean drinking water is extremely pressing. The purpose of this work is to apply innovative approaches to improve the means of creation and expanding the informativeness of interaction maps of water bodies based on bathymetric methods and Industry 4.0 technologies. In the European Union, the European Environmental Agency creates updates and annually publishes database of all water bodies in Europe and their compliance with European standards. This process has also started in Ukraine. There are specialized regional departments of water bodies in each region in Ukraine. The main function of such departments is systematic audit and monitoring of the efficiency of the use of water bodies. The Department of Water Objects solves the following tasks: creation of competitive directions for the use of water bodies, improvement of operation conditions of the agro-industrial market, regulation of water and property relations in agriculture, creation of new state-owned water bodies, support of the state policy of sustainable rural development. It is also impossible to achieve effective activity in this area without IT technologies. An example in the creation is the use of special interactive maps of water bodies. The use of interactive electronic maps leads to dynamic visualization of the latest digital maps, which makes it possible to create them with the help of...
I'm sorry, can you change the slide? Maybe you need...
Slides are not changing.
No.
You have launched your presentation, but you shared not demonstration, but slide mode of your presentation.
We look on the first slide. Okay, change.
Do you see changes?
Yes, it's another slide, yeah.
Another? I show now the third slide.
Yes, we show. Yes.
Yes, we show. And now I tell about the item on the fourth slide. The efficiency and visual understanding of aggregate information about the object in digital form increases. The functionality of electronic map is explained by the fact that it consists of a large number of layers. Such a complex of layers serves as the basis of typization of combining complex data. This map can be useful for the environmental monitoring, resource management, and disaster response planning. Two systems were considered as a geoinformation technology software tools, Google Earth and SoftFarm. In the global database of the Google Earth program, millions of satellite images of every part of Earth are stored. With the help of these images, it is possible to view a certain area in real form. The figure on the slide shows an example of water body with the given contours and cadastral number data using the Google Earth toolkit. One of the alternative program was the creation geographic objects is the SoftFarm, a cloud-based IT solution for agricultural producers, allows the amalgamation of data into a unified format. The system uses the Google Web Service, which has a digital map of water bodies located in real time. Having used SoftFarm's cadastral map, it was possible to easily view water plots on the electronic field map of any agricultural enterprise. This site has a clear search for cadastral map, which makes it possible to find a certain water object, and this information system has a large and informative database. The picture on this slide demonstrates an example of forming the contour of water body in soft form with the indication of the cadastral number. Appropriate algorithm of creation a database of water bodies were creation in both named systems. Initial data was received from the Department of Agro-Industrial Development of the Poltava region. As a result, images of more than 1,000 water bodies and their passports were created. Information was then 1,000 water bodies and their passports and economic effects of use of information systems was calculated. Nevertheless, despite the significant filling of the database of water objects, information about its specific subjects remains insufficient. Interactive maps in their current state don't have data on the depth of the water body, relief and structure of the bottom, the presence of underwater vegetation, as well as the presence of various foreign objects and inclusions on the bottom of the water body. The last factor is relevant against the background of human economic activity or the conduct of hostilities. In general, increasing the efficiency of using this interactive map is possible to explaining the capabilities of the generation of a 3D model of the water body. This will make it possible to determine not only the volume of water but also to assess the ecological condition of the object based on the digitized data on the structure of the bottom and the layer of aquatic vegetation. In turn, on the basis of the accumulated statistical information about the conducted surveys with the help of artificial intelligence tools, it is possible to make forecasts including long-term owners of the corresponding characteristics, taking into account their seasonal fluctuations. Solving this problem can be based on the bathymetric. To confirm the practical implementation of the proposed approach, experimental measurements of the bathymetry of one of water bodies were carried out using the echo sounder. Such devices are considered the most successful tool for measuring depths, determining the relief of the bottom, and other underwear characteristics. For this, the Deeper Pro Plus Fishing Echo Sounder, which is equipped with a GPS sensor, was used. It can be controlled from a mobile device as schematically shown on this picture.
Please change picture.
Yes. Thus we help the device. You can create depth maps, color underwater contour maps to obtain information about the density and uniformity of the bottom of the reservoir.
Yelena, excuse me, maybe you forgot to change slides because we see only the
I didn't forgot. I have done this, but I understand that you don't see. It is 12 slide. Do you see?
It is tribal meat.
Sorry. I want to begin from the beginning.
No. Continue with another picture. Yeah. You change it.
Do you see 11 slide? This is 11 slide.
Yes.
Yes. To determine how hard or soft the bottom is displayed on the screen, several factors should be taken into account: the color and thickness of the bottom line and the presence of the second signal reflection. In addition, it is possible to estimate the intensity of layers of aquatic vegetation on the trajectory of echo sounder. Experimental results you can see on this picture. As a result, to track the dynamics of increasing or decreasing depths, you need to move the sonar smoothly. It is possible to obtain a more accurate image of relief change and avoid blind areas during scanning by changing the signal frequency narrow beam mode to 190 kHz. The existing functionality of the software allows you to download all the data obtained during each sonar scanning mission to the cloud storage Deepfish Cloud. An example of viewing data from the cloud is shown in the figure on the slide. I hope you see it. The use of the neural network apparatus in the processing of bathymetric data.
No, we see only 11 slots.
The use of neural network in the processing of bathymetric data, echo sounder tracks containing information on the state of vegetation involves solving a number of tasks, which should include object detection, image segmentation, object classification, etc. Optimization of this approach is possible through the use of ready-made solutions, for example, for segmentation.
Yelena, have you finished your presentation because we do not see anything? Maybe there is some issues with internet connection with our colleague. Okay, maybe she. Okay, Elena.
Yes, I don't know what is the technical problems today.
Okay, maybe we'll. Can you continue, please?
No, I finished the report.
Okay, so okay, colleagues, have you any questions to our speaker?
Can I ask you a question?
Yes, please, Vyacheslav.
Dear Alena, please tell me how your picture that you show us correspond to your, for example, your 4.0 technology.
I didn't listen to the old question. As I understand, you asked about figures which I demonstrate on which slide. I demonstrate the figures the results which we obtained during creation of real body maps of real water bodies through Google Earth and soft farm information systems. Most of all, we also try to uh, moderate the informativeness of our maps and made different bathymetrics results, and also some of these results was processed by artificial intelligence methods, and I'm not sure that I can to show the presentation once more.
You don't need to show. I was interested only in how you communicate sensor IoT network, which Google Watch system, and you tell me the answer at this question. Thank you once again.
Thank you, Elena. Okay, let's move to another presentation because we have to keep the schedule.